Hey guys, the 2003 higher level junior cert question 6. The figure shows a design based on the elevation of a sports stadium. The curve ABCDE is based on a semi-ellipse. So A, B, C, D and E based on a semi-ellipse width, okay, major 100, minor 60. The focal points F and G are indicated. The lines BR and DR are tangential. Okay, perfect, to the ellipse at points B and D respectively. And the curve QRS is based on the same semi-ellipse. The curves AP and ET, so A down to P and E down to T, are semi-parabolas with the vertices A and E. Vertex A, vertex E. Draw the design showing all construction lines. Now, if I want to get started with this one, I know that I will need at least a 60mm space below the center of the drawing. It's not a very large drawing anyway, so I might just get started roughly around the center of my page. I'm going to start off by drawing the major and the minor. I'll draw the ellipse in that position, or the top half of the ellipse, and then I'm going to find my focal points. Okay, so to get started, roughly around the center of my page, major axis 100, so I'll be setting my compass to 50, minor axis of 60, so I'll be setting my compass to 30. So as I said, around the center of my page, I'll get going on this one here. It has a major axis of 100, so that's 50, and a minor axis of 60, so that's 30. And I'll go ahead and draw my major and minor auxiliary circles. Now we're going to use the basic method here. Because it is a horizontal ellipse, I know that that is a point in the curve, that is a point in the curve, and that is. And we're pressing down from the major and across from the minor. Okay, so there's the ellipse drawn. To find my focal points, the usual, half the major and the top of the minor. And I get my two focal points, and on this drawing they were labelled as F and G. So that was point F right there, and that was point G right here. This is point A here, and this is point E here. After that, then I had to add in some parabolas. I might just go ahead and do the parabolas first. I'll do the easy parts first. Pick up as many marks as I can. I'll just drop in a parabola here, going from A down to P. It is 60mm tall, 30mm wide, rectangle on each side. So tall and 30 wide. Now, where's my few steps here to drawing a parabola? Okay, so first of all is mark your vertex, which is already marked, and then it's to just mark the opposite sides. So here and here. Mark your two opposite sides within that rectangle. Next, we need to figure out, does the maths work out here? Can we divide up each side into an equal number of parts, or do we need to go ahead and use the construction? It's 30 and 60, so 5 equal parts works out just perfect here. 5, 12, 60, so 12, 24, 36 and 48 there, and 60, 5 12s, and then along the base 5 6 is 30, so 6, 12, 18, 24, 30. So that's, the maths works out perfect this time, no need for any extra constructions. Next step is number away from the vertex, so that is the vertex. Come on down to the base and go over to number 1. So away from the vertex, working from 1 to 2 to 3 to 4, and again start with the vertex, come across and go down to number 1, 2, 3 and 4. So next step is join the first point in the direction you want to take your curve. So do we want it to go down from the vertex towards number 1 and down here, or do we want it to go across here, across towards number 1? We want it to go across the page, so across to number 1 and up from number 1, and so on. We can do that for all remaining points across to number 2, 3 and 4, up from number 2, 3 and 4, and then we have all of our points in the curve. We have 1, 2, 3, 4, and a start and an end point as well. If I wanted to now, I can do this. This is the really handy thing about this. It's a symmetrical object, it's a symmetrical drawing, so I can take all of my points, finish point here, I can take this point, this, and I can mirror them across. Now I like to do the mirroring before I freehand in the curve, so there's absolutely no issue with seeing the exact points and setting your compass exactly. And the last one. So, I can draw a full solid base across the object from here to here, and I can freehand in my curves. There's one. There's the second. So, having a quick look back to the question again, we'll see how much we've answered. The curves AP and ET are semi-parabolas, that's done. A semi-ellipse with a major of 100, minor 40, and the focal points are found, that's done. The lines BR and DR are tangential at points B and D. So I need a tangent to an ellipse at a point on the ellipse. So this tangent right here, and then I need the same one over here. Now, where is point B and D? Well, they're directly above the focal point, directly above the focal point. So I'll go ahead and find points B and D first of all. So if I go directly above the focal point right here, to touch, I get point, what is that one called? That is called point B right now. And if I go directly above the focal point here on this side, I get myself point D. So, what we can also see is this, what they've called the top point, point R, so where B goes up and hits and where D goes up and hits, that is point R up here, and it lies on the center line. That would suggest that it's, again, it's symmetrical, so if I just find one tangent, I can join it up to the second point. To find the tangent, we simply join through the focal points. So for a tangent for a point on the curve, you join through the focal, and you join through the focal. And then you bisect your large angle here, or it would be the small angle inside here if it's the normal, and this angle here if it's the tangent. So if I set that angle there, I've got my compass. Now, with that angle now bisected, I get point R, which happens to be just below the major circle. And there's point D. So let's just see, we'll cross off as we go. Always a good idea in these questions. The lines BR and DR are tangential to the ellipse at B and D. Now, finally, the curve QRS, this curve up here, is based on the same portion of the ellipse from B to C to D. So basically what we're going to do is we're going to take the ellipse from B, C and D, and we're just going to slide it up or translate it. The distance is from C up to R, because we have point C and we have point R, so that's our distance. So we are taking the ellipse from point C in here up to point R, that's the distance, and we're going to just pick some points along the way and take them up the same distance. I'm going to do this in a different colour so that this stands out pretty well. And I'm going to take some, first of all, point D needs to go. I'm going to take the point that we already found there. I'll take one more in between them, and maybe two more here to the left, 1 and 2. So that's how many points I just took there. Probably wouldn't need quite that many. I had 1, 2 to the left, and or 2 to the right of this, and 1 to the left. And finally point B, which is already projected up there in pink. So we're sliding up all those points, or we are translating them. When you do a translation, it's all about distance and direction. The direction is already done for every point. The distance is C to R. So I'll start here at the side, and I'll just start marking all my points all the way along. There we go. So, Junior Cert Higher Level 2003 question 6, and that's it, complete. Not a very difficult question, just I suppose posed in a slightly different way. Point R would have been the point that would be a little bit problematic if you were looking for a measurement and a height, instead of realizing that you just, when you have your focals, you join them through, bisect and get your tangent. That gives you the height of R. Very simple little translation there as well for B, C, D, up to points Q, R and S. I hope this video helps, and thanks very much for watching.